Welcome to Knowledge Base. Let us look at the factors affecting the resistance of a wire. These are the length of the wire, the cross-sectional area of the wire, and temperature. How does length affect the resistance? The resistance of a wire is directly proportional to the length of the wire. It means that the longer the length of the wire, the higher the resistance, and the shorter the length of the wire, the smaller the resistance. In terms of cross-sectional area, the resistance of the wire is directly proportional or is inversely proportional to the cross-sectional area. It means that the smaller area will produce a larger resistance, and a larger area will produce a smaller resistance for the wire. It means that thicker wires have smaller resistance while thin wires have higher resistance. Now, for temperature, the resistance of the wire is directly proportional to the temperature, which means that the higher the temperature, the higher the resistance, and vice versa. But we are going to study this under a constant temperature. So under constant temperature, we can combine these two proportionalities and have that the resistance is directly proportional to the length of the wire and inversely proportional to the cross-sectional area. What it means is that long, thin wires have higher resistance, while short, thick wires have smaller resistance. If we remove the proportionality sign and change it to equal to, we introduce a constant, ρ. This constant is known as the resistivity of the wire. This is an important equation to take note of in calculating the resistance of a wire. Rho stands for the resistivity of the wire, and the resistivity of a wire depends on the material of the wire. It is a constant, but it varies from materials to material. For example, the resistivity of copper is lower than the resistivity of aluminium, which means that copper conducts electricity better than aluminium. Now, let us look at the resistivity by making it subject of the formula. If we make ρ subject of the formula from this equation, it becomes resistivity equals to Ra all over L, which means that the resistivity of a wire is equal to the product of the resistance times the cross-sectional area divided by the length. This is also an important formula to take note of. If we consider the units of this right-hand side, we can be able to tell the unit of resistivity. The unit of resistance is ohms times the unit of area is meter square. The unit of length is meter. So if we take this fraction, meter square divided by meter, we will be left with meter, so that the unit of resistivity becomes ohms meter. And we can conclude that the unit of resistivity, ρ, is ohms meter. So these are the formulas affecting the resistivity of a wire. I hope you enjoyed this video, and thank you very much for watching.